Hello everyone, this is Ali Reza. In this episode, we will continue with our input outputs both on the node input output and our node schema input output. Well, node input output. First node input, well, guess what? It's a serializable. Everything in your graph should be serializable, don't forget that. And I think I didn't mark my inline value as a serializable, did I? I hope I did. Yeah, I did. Okay. Now, lazy guy. So, it will have a serializable field, a public one that has a list of node, and we call it parent node. Holy crap. Yeah. Also, it will have a serializable field, public connection that we don't have yet of connection. Okay? So each input can have a list of nodes as its parent. Well, we have a constructor that has nothing in it. Here we say parent node equals to new list of node and connection equals to new connection. The rest will be added later. So we will come to this guy later on. The node output is almost similar to node input, almost. So it's serializable. It has a serialized field of public list of node, and we call it child node. Okay? So each node that has an output can have as many as we want children. Then we say public connection, again, that we don't have yet. And no, I said connection, that we call it connection. And of course, it's serializable. So we have a constructor that says child node equals to new list of node and connection equals to new connection. And I'm not happy with the naming here, so I will make them plural, child nodes or children. And here I will call them parents. That's better naming. Parents. Parents. And here is, if I can type, children. Now, the only thing remaining is in here implementing the connection. Now, connection. Can you guess it is serializable? And it will have serialized field of public list of connection key. Okay? That we don't have. And we call it list. A constructor that has list equals to new list of connection key. And then another constructor just in case for this guy. Okay? And that's it. Now we need to make the connection key. Connection key. And again, connection key is, ouch, look at me, serializable. It has a serializable field, but these guys are private, so private, a list of int as values, a private string as keys. Okay. Then we have a constructor that has nothing. Oh, yeah, and it's key, not keys. So here we say key equals to empty string and values equals to new list of integer. Then I will have another constructor that has both of them, and yeah, we have some methods. So we have public void connect. Connect accepts a string of key and list of int as value. Okay, values. All it is doing, it is saying that, hey, the key equals to the key we sent in, and the values, come on, not minus, values equals the values we sent in. It's not a constructor, it's just a method. Okay, although it's the same stuff, but it's not a constructor. So then we have public void reset that says basically this. Boom. Then we have public void set key to the string key, and simply say key equals to the key we sent in, and right now I can say, hey, set key to the key. So I'm using my own methods. Then we have not partial public void set values, and we put in a list of values. All we do, we say values equals to values, and now I can use that and say, hey, set values with the values we sent in. Okay, after that we want to take a look and say public boolean has key, the string key. Okay, all we do, we return if our key is equals to the key we sent in. Then we want a public boolean has, has value, and we return as we sent in an int as value. Here we say we say return values dot contain the value. Okay, then we have public void add value, and we sent in an int as value. Here we say if has value, the value, throw new argument exception. The exception we want is a string dot format, and we say the value 0 already exists in the connection list, and that is our value. And because it's exception, it will break the point, so we can say if the values equals to null. So if we don't have anything, then we say values equals to new list of integer. Then we simply say values that add the value. Okay, so we want to basically put it before it here. Yeah, that's a better language there. Now remove value, so public void remove value int value. We are doing the same stuff here, but here we say if not has value, the value does not exist in the connection list and break, and we say remove. Okay, and here if the values is null, well, I was trying an exception here, null reference exception, but let's just create it. Why throw an exception when we can do this? So we say public list of int values. We simply get, and it returns the values. So a property for that. And this is not what I want. This is what I want. A public string key that gets the return of our key. And that is our connection key. Now, we have the connection key, we have the connection, and we should be able to use these here. Cool. Now, node input schema. Node input schema is a bit more involved. So it's serializable, and it has, I didn't have that, okay. This part, basically. Yep. And all of them are public, by the way. So public bool, it is occupied. It means if this input is already connected to any output or not. That's all to it. So public vector2, and it is the position. So position of this output inside the boundary of the node. Then we have a bool that says multi-connect. Can we connect this input to more than one output? So basically, if this node can have more than one parent. Then we have a public list of node schema, and this is parents, just like the input relative. So we can have more than one parent. And then public connection, and we call it connection. And then a public node input, and this is related input. So as you see, anything that has schema has a related thing to the non-schema corresponding it. Okay? So now we have a constructor. The constructor says the parents equals to new that. The connection equals to new that. And multi-connect equals to true by default. So each input can have more than one output, more than one parent. That's the meaning of this line, okay? And then the rest will come later when we are playing with these classes and the nodes themselves. Node output schema is again serializable. You should get used to it by now. Then we have a public bool is occupied, means that if this output is connected to any children. So vector2 position. I'm not sure if I'm using this position at all or not anyway. But yeah, I think I'm using it for drawing the connections. Okay, the position, then a list of node schema as its children, then a connection as our connection, then a boolean for multi-connect. Again, same concept, connect. Then a public node output as related output. And that's it. So we have a constructor, and here we say children equals to new that, connection equals to new that, and multi-connect equals to true. That's it. And that is our node input and output, very basic implementation. And in future, these things will have some methods, some things in it, but we will come to them later on. Now, by just putting these guys, we have the very basic infrastructure that we need for our node graph handling. And you see that I don't have anything in node graph itself. I have some views, especially the toolbar. And I will have some utilities that I will add later on, I think inside here, anyway. And yeah, so why are you yelling at me? Boss, common editor, editors, base view. Ah, not again. Not this again. Yeah, basically, the thing is that why are you not happy? Boss dot common dot editor dot editors dot base view. Stupid guy, it's there. boss.common.editor. Utility.editor. Common.editor. And I think that was the reason. Not sure, but maybe. And this is common. So if I hit Ctrl-Shift-R, adjust namespaces, it's okay. Ctrl-Shift-R, adjust namespaces, that's okay. And Ctrl-Shift-R, adjust namespaces, that's okay. Huh. And now it's working. No, it's not working. Port the namespace. Stupid thing. Every now and then, it's just bothering me. The thing is that the editor is a very special name when it comes to Unity, and yeah. For example, common.editor. Yeah. Well, it should be possible. It should be available. What if I set you as the startup project? Huh. Derpy, derpy, derp. It's referencing it. And I have 2 resources now. Interesting. That was one of the problems there. And it's not exist anymore. Really? I hate when this happens. Partial. And one of the errors is here. We don't have this. So texture, public, static, read-only, texture 2D. That equals to graphic utility. Dot load texture, the same stuff as the name, comma 32, comma 32. That. Now that one is happy. This one is happy. And now this one is happy. Interesting. So all the problem was that a stupid way of problems here. I'm not sure. Well, anyway. Yeah, we have a tools bar. The tools bar is responsible of, creating a graph, deleting a graph, loading a graph. And now that we have the basic infrastructure, we should be able to handle those stuff. And we have very bare minimum of things that we need to make it happen, We really have the things that we need to, I think we have. Let me double check, triple check everything. Yeah, we should be able to, oh, wait. Yeah, we need to first put this guy's on GUI, update view, I mean. And then when we've done the update view, well, we basically are done with this class, and it should be able to do stuff. Although we will come to this guy later in the future, I think. Or maybe not. Maybe yes, maybe not. We will see. So, next episode, we will start working with toolbar view, because, well, we need to start somewhere to make things work in Unity. And that is where I will start, with toolbar view. So until then, have fun, everyone. Bye-bye.